on pages 80 and 81 of our textbook, lesson 4 of unit 3. We'll be practicing simplifying radicals, and we'll start with simplifying perfect square roots. What is the square root of 9x squared? Well, we know it's 3x. What is the square root of x to the 8th? Recall that square root is the same as the exponent 1/2. So if we have x to the 8th raised to the 1/2, a power to a power, we multiply those powers. 8 times 1/2 is 4. So the square root of x to the 8th is x to the 4th. The square root of 36, x to the 36th. Well, the number 36, the square root of 36 is 6. And the square root of x to the 36, take the 36, multiply it by 1/2, and we get 18. The square root of 49, x to the 20th, y to the 16th, z to the 12th. Well, the square root of 49 is 7. Now with our exponents, take each exponent, multiply by 1/2. 20 times 1/2 is 10. 16 times 1/2 is 8. And 12 times 1/2 is 6, z to the 6. So we have 7, x to the 10th, y to the 8th, z to the 6th. However, if the radicand is not a perfect square, there's another step to take. We only consider a square root simplified when all its perfect square factors have had their square roots evaluated. To simplify a radical, express the radicand as the product of factors. Remember, the radicand is what's underneath the square root symbol. The largest perfect square, or cube, or nth factored, followed by the non-perfect square, or cube, or nth factors. Find the root of the perfect factors from A. This is the coefficient of the radical answer. And the B part is the radicand of the radical answer. So first, let's make sure we know our perfect squares: 4, 9, 16, 25, 36, and so on. And then perfect cubes, 8. The cube root of 8 is 2, because 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. Other powers you should know: 2 to the 4th is 16, 3 to the 4th is 81, 2 to the 5th is 32, and 2 to the 6th is 64. Simplify each of the following square roots. The square root of 50. Okay, so we are going to, we're thinking to ourselves, what perfect square times what will give us 50? We know that 25 times 2 is 50. So I'm going to rewrite this as square root of 25 times 2. And I suggest you do the same in that now I'm going to circle the perfect square portion of this. Out comes its square root. What is the square root of 25? It's 5. So 5 comes out, and that what's not circled remains, square root of 2. And that's our answer, 5 square root of 2. The square root of 700. We're thinking to ourselves, what are the factors of 700? What times what is 700? 100 times 7. Circle the perfect square factor. Take its square root. The square root of 100 is 10. And then what's not circled stays, square root of 7. So 10 square root of 7. Square root of 72, xy to the 4th. Okay, now 72, you may be thinking 9 times 8 is 72, but there's a larger perfect square that goes into 72, and that's 36. 36 times 2 is 72. We cannot do anything with x, that just stays. And the y to the 4th. Y to the 4th is a perfect square. Again, circling our perfect squares now. Out come their square roots. Square root of 36 is 6. The square root of y to the 4th, 4 times a half is 2. So that's y squared. What's not circled remains. So 6y squared, square root of 2x is our simplified answer. I can circle that one. Again, so it would be very helpful if you had a different colored pen or pencil. The square root of 32, x to the 5th. The largest perfect square that goes into 32 is 16. So I'm thinking, okay, 16 times 2 is 32. Now, x to the 5th. Well, we're looking for x to an even power. What's the largest even power less than 5? It would be 4. So we would write x to the 5th as x to the 4th times x. Circle those things that are perfect squares, which in this case is 16 and x to the 4th. Out come their square roots. Square root of 16 is 4. Square root of x to the 4th. Take 4 times it by a half. That's 2, so it's the power of 2. And what's not circled here remains underneath the square root symbol. So 4x squared, square root of 2x. Number 5, square root of 18x to the 4th. 9 times 2 is 18. As long as we're looking for square root, as long as our exponent on our variable is even, then it's a perfect square. We can take its square root. Square root of 9 is 3. Square root of x to the 4th is x squared. And what's not circled, square root of 2 remains. Number 6, square root of 200x to the 5th, y to the 3rd. Okay, 200, that's 100 times 2. X to the 5th we will break down into x to the 4th times x, and y to the 3rd will break down into y to the 2nd times y. We can take the square root of even powers. Okay, circle what are perfect squares. Out come their square roots. Square root of 100 is 10. Square root of x to the 4th is x squared, and the square root of y squared is y. What's not circled here, the 2, the x, and the y remain underneath the square root symbol. Square root of 147, x to the 9th, y to the 4th. 147, I'm not sure. I'm thinking maybe 49. 49 times 3? Yes, 49 times 3 is 147. You can double check that with the calculator if you want. Okay, so this is 49 times 3. X to the 9th. Remember, we're looking for square root. So we want an even power here, so we'll rewrite x to the 9th as x to the 8th times x, and y to the 4th. Again, as long as we have an even power, that is a perfect square. We can take its square root. Circle the things that are perfect square. So in this case, I'm going to write down what's going to remain, and that is the square root of 3x is not circled, so I'm bringing that down. Now here, what is circled, out comes their square root. Square root of 49 is 7, square root of x to the 8th is x to the 4th, square root of y to the 4th is y squared. Square root of 128, x to the 16th, y to the 10th. Let's see, 128, I'm thinking 64 times 2. And x to the 16th and y to the 10th are perfect squares. What's not circled remains, so the square root of 2, square root of 64 is 8, x to the 16th is x to the 8th, and y to the 10th is y to the 5th. Number 9, square root of 75, a to the 12th, b to the 100th. Okay, 75, 25 times 3. A to the 12th, 12 is even, 100 is even. Circle our perfect squares. Take out their square roots. Square root of 25 is 5. Square root of a to the 12th is a to the 6th. Square root of b to the 100. B to the 100 times a half is 50. Square root of 3 remains. So 5, a to the 6th, b to the 50th, square root of 3. Here we have some higher order roots, right? The cube root of 16, right? So remember our perfect cubes. 8, 27, 64, 125, right? So if I'm looking at cubes, I'm just going to write that down on this page. So the cube root of 8 is 2, 27, 3 cubed, 64 is 4 cubed, 125 is 5 cubed. Okay, so the cube root of 16, so we want to break 16 down into two factors, one of which is the largest cube root factor, which would be 8. 8 times 2 is 16. Let's circle the perfect cube, which is 8. Out comes its cube root. Cube root of 8 is 2. And then what's not circled remains. Cube root of 2. B, the cube root of 108. Let's see, I think 9 times 12, so it's got to be 27 times 4. 27 times 4 is 108. Let's just check that. 27 times 4. Yes. Cube root of 27 times 4. 27 is the perfect cube. Its cube root is 3. I wonder if it would be helpful if I write that as 3 and then, yeah, I think I'll do that. I should have done that on the other side. So that's 3, cube root of 4. Cube root of 250, 125 times 2 is 250. Circle what's the perfect cube. Out comes its cube root. Cube root of 125 is 5. And what's not circled remains. So 5, cube root of 2. Go back and circle these. D, the cube root of 128, x to the 8th. 128, 64 times 2 is 128. Now, x to the 8th, we would like this to be a multiple of 3, right? So we'll break x to the 8th down into x to the 6th times x squared. Circle those things that are perfect cubes. The cube root of 64 is 4. The cube root of x to the 6th, this is going to be, you take 6 and multiply it by 1/3, which is 2. And what's not circled stays. Cube root of 2x squared. Next we have a fourth root of 162. 162. Oh, is that 16 times something? Fourth root. Oh, 81 times 2. Did we go over fourth root on the other side? We did. We had 3 to the 4th is 81. 2 to the 5th is 32. 2 to the 6th is 64. Alright. So 81 times 2. The fourth root of 81 is 3. So 3 fourth root of 2. The fourth root of 16x to the 8th. Well, these are both perfect factors. The fourth root of 16 is 2. And take x to the 8th, take the 8, times it by a half, right? By a fourth. This is the same as x to the 8th raised to the 1/4. So 8 times a fourth is 2. So the fourth root of 16x to the 8th is equivalent to 2x squared. G, the fourth root of 48x to the 10th, y to the 5th. Let's see. 16 times 3 is 48. X to the 10th. Okay, it needs to be, we need to break this down into a multiple of 4. So per 10, I'm thinking that'd be 8. So x to the 8th times x to the 2nd is equivalent to x to the 10th, right? Because when we're multiplying, we add exponents. And y to the 5th, we would break down into y to the 4th times y. Let's circle those things that are perfect factors. The 16, the x to the 8th, and the y to the 4th. Take out their fourth roots. 2x to the 8 times a fourth is 2, and y to the 4th, so thinking 4 times a fourth is 1. What's not circled remains, which is the fourth root of 3x squared y. Here we have a fifth root, 64. 2 to the 5th is 32. So this is 32 times 2. Let me not forget our root here of 5. X to the 12th. We're going to break down the 12 into the largest multiple of 5 that goes into 12, which would be 10. Or not goes into 12, but is less than 12. Largest multiple of 5 less than 12 would be 10. So this would be x to the 10th times x squared, and y to the 15th. 15 is a multiple of 5, so that can stay. So y to the 15th. Let's circle our perfect factors. The fifth root of 32 is 2. The fifth root of x to the 10th, you're taking 10, timesing it by 1/5, which is x squared. And the fifth root of y to the 15th, 15 times a fifth is 3. So 2x squared y to the 3rd, fifth root of 2x squared. Okay, some more simplifying. Here we actually have something outside of our radical. So this is 2x times the square root of 18x to the 7th. So we simplify the radical first, and 18 we're thinking 2 times 9. X to the 7th we'll write as x to the 6 times x. Let's circle those that are perfect squares. Out come their square roots. 3x to the 3rd. What's not circled remains, 2x. And then we bring down, let's bring this down, bring down our 2x. So this is now 2x times 3x to the 3rd times the square root of 2x. Multiply 2 times 3 is 6. X times x to the 3rd is x to the 4th. And bring down the radical. So 6x to the 4th, square root of 2x. B, 98. Is that 49? Times 2 is 98. This would stop. Okay. So this is the square root of 49 times 2. X to the 5th we'll write as x to the 4th times x. And y to the 8th is a perfect square. That stays as is. Circle the things that are perfect squares. Out come their square roots. Square root of 49 is 7. Square root of x to the 4th is x squared. Square root of y to the 8th is y to the 4th. What's not circled remains, square root of 2x. Bring down the 3x squared y, that was out in front of our radical. And now multiply 3x squared y by the 7x squared y to the 4th. 3 times 7 is 21. X squared times x squared is x to the 4th. Y times y to the 4th is y to the 5th. Square root of 2x. C, we have cube root. 64. That is a perfect cube. X is 12. 12 is divisible by 3, so that's fine. We just have to break down y to the 14th. So square root of 64. X is 12. Y to the 14th will break down into y to the 12th times y squared. Circle those things that are perfect cubes. Out come their cube roots. 4, x to the 4th, y to the 4th, cube root of y squared remains. And D, the cube root of 375, x to the 7th, y to the 11th. Well, 375 is 125 times 3. X to the 7th we'll write as x to the 6th times x. We need a multiple of 3. And the largest multiple of 3 less than 11 is 9. So this would be y to the 9th times y squared. Circle those things that are perfect cubes. Out come their cube roots. 5x squared, y to the 3rd. What's not circled remains. Cube root of 3x y squared. And thank you very much for your attention.